Newton divided by kilogram, that's meter per second square. This is 1.6 meter per second square. This is the acceleration. That's it. We follow the steps, we follow the steps. Is there any other way? Can you be in Hialeah, all this, and say the acceleration is 1.6 meters per second square? No. No. I mean, there is a method. And that method leads you to the acceleration. There is no other way. And the method is those sequence of steps. Part B. The part B, I am asking for the normal force. Normal force is a particular force, and for that, because I am looking for a particular force, I said other than the gravity. You have to apply the Newton laws to find any particular force. Which, now I don't have to follow the same sequence, because I have already step number 1, I have step number 2, I have step number 3, I have to come back to step number 4. Which Newton law and along which axis, if I am looking for the normal force?
First Newton law.
First Newton law, why?
Y-axis.
It's along Y, and along Y what is happening?
No acceleration.
The object is not moving. Unless, let's say that if it's a boot back, and the wheel on the boot back are back, it will go along X and along Y, because one wheel is back, right? But in this case, if they are good, you can see that this is going only along X, not along Y. Good. What will be sigma F along Y equal to 0? So we are applying the Newton first law. What is the next step? Number 5. What is the algebraical addition of all forces along Y?
Normal force plus
Normal force
Fy minus mg.
plus Fy
Minus mg.
minus Fg, which is, what is Fg? Mass times gravity. So you replace.
Equals 0.
Equal to 0. This is my algebraical addition along Y, which is clear from the free body diagram. What will be the normal force then? The normal force, which is what I am looking for, is mg plus or minus the force times what? What is Fy? Times delta. This will be the normal force. So the normal force is mg, which is 10 times 10 minus 20 times sine 37, which will be 12. And this will be 88. 88 Newton. My question now, is the normal force the same than Fg? Is the same than Fg? No. So the tendency of all students in physics classes is to say every time, normal force is Fg. Wrong. Normal force is only equal to Fg. If it's at rest like this, nothing is acting. In that case, Fn minus Fg is equal to what? 0. So Fn is equal to Fg. Or if I am pulling horizontally, look, if I am pulling like this, the normal force will be the same than Fg. But if you are pulling like this, no, it's not the same. How much is the mg for that box? How much is mg? Imagine that this is the box. How much is mg? 100. How much is the normal force? 88. Why is 88? Because when you are pulling like this, you are lifting a little bit off here. You are lifting a little bit. The electrons there are not as uncomfortable as are now. You are lifting a little bit, and you are releasing the force. So the force has to be less. What will happen if I do this instead of that? I do this. Like in the vacuum cleaner. It's more or less? More. Look, imagine that I do this. How will look my free body diagram? What will be the difference? This will be like this. So how will be my Newton law along Y for this situation? If you can see, without the free body diagram, tell me. What will be the net forces along Y in this situation?
Normal force equals
What will be? Normal force up
positive
minus mg, and in which direction is Fy? Down, equals 0. This is the Newton law in that situation. It's different. So what will be Fn then? The summation of mg plus the force that I'm applying along Y. So how much will be? If this is 88, how much will be in the opposite case? 112. Can you see that? So 112, so it's 12 Newton more, which is what I'm applying downward. So the Fn will be equal only to Fg if you are moving, if you are applying a force horizontal, or you are not applying a force at all along X. In that case, yes, the normal force is equal to mg. Any question? All right, this is the second problem, and the last problem. That's it. That's it for today.